Hello, Dr. Brow.
Oh, hello. You must be one of the treehouse detectives. I just spoke with Dr. D on the phone, and he said you were coming over.
We're trying to figure out how scientists can predict if a tropical storm will get bigger or smaller.
I definitely can help you with that.
We learned about LIDAR before, but we could use a review. Can you help us?
Certainly. LIDAR is an acronym that stands for Light Detection and Ranging. It's a pulsating instrument that is used to probe the atmosphere. Let's take a look now at how laser light scatters in the atmosphere. You've seen a laser pointer before. If you would pass the beam from the pointer through this plume from the vaporizer, you'll see the scattering from the small particles, just like a LIDAR sees in the atmosphere.
Wow, this is neat.
And if you would imagine using a pulsed laser, we could see where the scattering is and how much is there, much like a laser radar.
But how do you measure water vapor with a LIDAR?
Well, come on, let me show you. Take a look at these two laser beams. Now you can slide the container of colored water into the two beams and see what happens.
The green laser light almost disappears.
Exactly. And by comparing the intensity and how much changes in the green light, we can calculate how much dye is in the cell.
So you mean you can detect the amount of water vapor by comparing how two laser lights change when water vapor is present?
Exactly. Let's go see a LIDAR that's flown around a hurricane. This LIDAR system is called LASE. LASE stands for LIDAR Atmospheric Sensing Experiment, and it was designed to go onto a very high altitude airplane. When LASE is flown on an airplane around a hurricane, we can make measurements of how much water vapor is flowing into the hurricane.
We learned that water vapor feeds the storm.
You're right. Water vapor is the primary energy source that drives the hurricane.
Why would NASA want to fly around hurricanes?
The information we gather with our experiments should help us to better predict hurricane behavior. And we hope to develop very small LIDAR systems that can go on unmanned aerial vehicles, or UAVs, which are small model aircraft.
Why would you want to put LIDAR on such small planes?
Well, a UAV can fly around a hurricane for several days and get the information we need to help better predict what the hurricane will do. In the future, we hope to develop a LIDAR system to go into space to do the same thing.
Wow, that would be really awesome. Thanks, Dr. Brow. You've been a big help.